We're joined by Gianni Martinelli, who's the head of Gimar Golf, who a specialist forging company based out of Switzerland, who we've had the joy of having their products in the studio for a number of years. But here to talk about forging and its practices within the golf industry, which is somewhat different to applications outside of, but some of the products, but actually about the process itself and the benefits of a high quality forging process. So firstly, Gianni, a little bit about yourself, just so everyone knows your background.
Well, yes, thank you, Simon. I'm very happy to be here, and of course, I'm very honored to work with Precision Golf since years. And I really hope we can extend our cooperation. And thank you also for all the advice you gave me in the past. You see that I'm also following them.
It's a pleasure. Yeah, it's a pleasure.
It is my special pleasure to follow your very expert advice. Well, I come from a family in the forging industry. I had the fortune to go to higher education. I studied mechanical engineering first, and then a master in metallurgy and a PhD here in the UK, which was for me a very, very important technical school, but also school of life. And then I spent my life in the forging industry. I ran for a precision forging company for 20 years, and in the past 20 years, I am running Forging Technologies, which is an engineering company, as you said, based in Switzerland, and we supply engineering consultancy in forging worldwide.
And majority of that is it within particular industries of aerospace, transport?
Yes, I would say that the majority of our customers, they are producing components for aerospace, for the vehicle industry, for oil and gas, for the medical industry in the sense of orthopedics. And recently, as you well know, we started doing something in the golf business.
Yeah. And forging I think in golf, we understand forging to be the production of a softer feeling metal, but really for those industry, it's a pressed material. It's a solid material pressed into shape, versus casting, which is a liquid form metal poured into a die and then heated to set it. In very, very crude terminology, kind of difference between forging and casting. But from a technical point of view, and for those of you that like the technical aspects and want to geek out on what actually goes into golf clubs, Gianni is your man, because you'll be able to explain in some detail as to what actually, why would we use forging in golf?
Yes, well, thank you very much. I think, Simon, your explanation is not so crude, is fundamentally correct. There is, unfortunately, a large amount of confusion in the golf industry between casting and forging. I mean, it's right what you said. Casting, it means pouring liquid metal into a mold or a shape, and the metal, when it solidifies, it takes the shape of the metal, but without the development of any specific properties. In the case of forging, it means that we are taking our material, our alloy, to the maximum ductility temperature, which varies depending on the alloying content. And then we forge it under pressure, which means that there is a compaction process. And this compaction process, if it is done correctly, it produces also a certain directionality of fibers.
Yeah. So grain flow.
A grain flow, thank you so much. I mean, every forging is producing a grain flow, but there is a level of confusion even here, mainly in the golf industry. Of course, the grain flow takes place during the formation, but the possibility of giving a directionality to the grain flow then is left to the forgers, is left to the knowledge of the forging process and the way tooling and the process itself is developed.
And so within, specific to golf industry, why would you, is there a particular process which is optimal across the board, depending on, from a kind of a golf club head forging process, or again, I'm highly likely going to be depending on what you're wanting to achieve with that head, you would adjust the manufacturing process, the materials used, within forging there, the presses are different weights and applied at different speeds in different ways. So using each of those elements from the myriad options that you've got at your disposal, you'd use those to adjust the way the product's made to suit the functionality of it.
Yes, I would say that in the golf industry, generally speaking, forged golf heads are produced via the very normal conventional forging process. I mean, it means heating material, squeezing it, and then in most cases reworking it, cleaning it, and so on. This is what is generally made, which doesn't mean it's not good. Of course, the properties of forgings produced with this conventional way, they're very different from those producing by casting, of course. So it is in any case a forged club. In our particular case, due to our background, there are people talking about forging, but they never actually forged, or they never actually produce a precision forging. In our case, this is our life. So we live out of precision forging, and therefore our approach is completely different. We design the process in a different manner, and we distribute metal in a different manner, and we apply principles which can be simple, but that they are essential if you want out of principles of physical metallurgy.
So the key thing that differentiates the process that you use versus ultimately the traditional forging method that golf employs most of the time?
Yes, the key issues, without going too much into details, is that first of all, the basic material is the same, without going into details. Probably belonging to well-known families, but we use still different materials. And the way we are designing the process is essentially different. I cannot go too much into details, but in any case, it is different. And we forge a golf head in the same way as we produce a safety critical component for other applications, which is, normally speaking, for the forging industry out of consideration for obvious economical reasons. If you have to satisfy certain economical aspects, then of course you have to forge in the simplest possible way. It is not our case, not because we are, a non-profit organization, but because our principle is slightly different, and forging is not our main activity. We try to combine it with the rest, and thanks to that, we produce short runs of forging with different properties, of course.
And one of the keys to what are the keys to a well-made forged product? We sort of talked a little bit earlier before coming onto the cameras about what constitutes a well-forged product in terms of, from a material point of view, what the forging process does to the material to get rid of imperfections.
Well, very important, is essential to start with the right material. I only call it right. I don't tell you more than this, but right is very important. And then you have to have a deformation process really closing the dies perfectly without creating so-called forging defects, which can be created during the forging process. And then again, our aim is not really to create forged heads. I know it is the aim, it is the general aim in the forging industry, in the golf industry, which is fair and good. And our aim is to produce precision forged golf heads. This means that the golf heads you receive and your customers are playing, they are just forged. They are just forged and cleaned, but they are not remachined. Nothing is touching them, and therefore there is a very big difference in the tooling design and in the process between designing a forging and designing a precision forging, or designing a precision forging with certain characteristics. This is what we want to do, because this is what distinguishes ourselves from others, and that's the reason that we are still alive in a very competitive industry. Because if we would produce forging like everybody else, probably wouldn't have a chance.
And I think with going into what you're saying about just a precision forged club head, in your instance, it's the other companies will produce a base forging and then marrow in a face, add other materials to it, weld other pieces together, which then alters the molecular structure once beyond when it's been forged. So you might start to actually might lessen the quality will lessen the quality of the material every extra step and extra layer of material that you add into the.
Well, Simon, yes, thank you that you mentioned all this. Is very important. Again, there are producers that they produce rough forging and then they machine it, and some of them they add plastic on it, and they paint in a certain way to correct the surface defect, to make it clearly. Furthermore, there are people talking about precision forging and they weld together the pieces. I mean, I have to tell you that on a scale of 100, if you produce a closed die forging with precision forging tolerances in one piece, or if you produce it in two pieces, there are two different worlds, of course, and two different difficulty levels. And from a golfing standpoint, I mean, the forging and the head have for sure different properties. I mean, when you weld something, it doesn't mean it's bad, can be good, but surely with different properties between one portion of the component and the other, that's for sure.
And that'll affect the way that the structure supports load, and I guess the stresses that go through the head and the consistency of
very
how
much
that
so.
reacts head to head.
Very much so. And these, to my very poor, how can I say, golfing technologies, knowledges, but it should affect what in the golf industry is called feeling. In any case.
Yeah. And that's the one thing that
is a
forged
transmission of
club,
sensation, I think. No?
I mean, a forged club is the one that everyone understands to be a nice soft feel. The better players clubs, and the technically the less forgiving better players, low handicap players clubs are forged because one, the softer feel, two, the extra ability to, the malleability of the material. So in a casting, it's hard and brittle. In a forging, in whatever shape or form, you've got the ability to bend and move it, which also helps the adjustable nature of the better players clubs to fine tune them in. But the simpler shape lends itself to a pressed forging process, whereas some of the structures and the shapes and the I guess the shapes of the heads in a bigger, more forgiving head. Lend themselves to a casting process, but that's also a cheaper process and keeps pricing down.
I agree entirely. I agree entirely. And you saw in the past that, on many forging magazines, on this side and on the other side of the Atlantic, we were reading that cast forge for everybody and forge club for the good players. The reason behind that is that with poor forging technology, call it like that, it is difficult to produce a nice cavity. And therefore, the some of the cavity bags around, they are difficult to play. That's the only reason. But if you have the technology, and of course you are ready to spend some money on the process by designing a different process, then even with via the forging method, you can produce a full cavity bag, as we are doing. You see, and this means that even higher handicapper, you see, they can play they can play with a forged head and have the right feeling and make sure that the ball is flying the way they want. That's also very important. That was also one of my aims.
So what got you into golf, or into the golf club head manufacture?
Also, I never thought about that. For years, I was reading impossible stories in the golf magazine, and but I never took really the initiative or doing something. I was very busy doing other things, and then a well-known American manufacturer of heads hired myself as a consultant. They wanted to, how can I say, to restore their metallurgical knowledges and make sure to know what is what, and designing something which was forged in a different manner that they had in mind, and so on. And then I did an important project with them, which came out with the design of a series of wedges which are still sold today after many years. And then I didn't do anything for the golf industry for a long time until a Swiss professional massaged me, convinced me to do something. And I then produced a series of wedges for my friends as a Christmas present. And after that, they started hitting the balls when spring came in my country. And then they start calling me saying, well, the noise is totally different from the rest of what we know on the market, and the ball is flying in a different way. And at the end, they convinced me to design the first series, which I did, which is the NRBX of today. And then, after having taken the decision of working exclusively with professional fitters, and I am in the right place to say that, of course, the fitters, after the first year, they came to me and said, we are not living with the low handicappers, we are living with the public. And therefore, please do something else. And I designed the second series and so on.
So we've got some of those products here, and the X is on the screen there. But I guess two of the more original products, we've got I'll put them up to camera, the NRB Pro and then the NRB 2. So you can see with the 2 on the top, there's more depth to the cavity at the bottom, more of a muscle located weight in the back of the NRB Pro. Very, very traditional shape, whereas the NRB 2 a little bit more offset, a little bit more forgiveness. So I guess with these two being, I guess, very much more a traditional shape and style of head. When creating these, what was your key or primary objective when you're creating these heads?
Also, first of all, I never really thought of reinventing golf heads or iron heads, but my idea was to do something better from a metallurgical and mechanical standpoint, which is what we did. Answering to your question, this was our second series, and with this, I wanted to produce a net shape cavity back, which is, as you said, is a pretty universal club. We are still doing well with these. And after that, we had some very good players and some good fitters coming to us and said, now we need something for the good player. And their idea was, why don't you produce a blade? No problem at all. I could have produced a blade, but then I got from some of the fitters the idea that not many players would use it. Some of them would put it under the bed or over the chimney. And therefore, you see, I come to the idea that by producing a muscle back with a small blade would have been the right thing to do. And in fact, this is what is appreciated by our fitters. This doesn't mean that sooner or later, if there is a high request, I can always produce a blade. But I think that the moment, this was the club which was mostly required.
Yeah, and I think what this club head gives you is that kind of nice sort of happy medium where you've got a little bit of perimeter weighting, a little bit of help, but then that extra bit of weight behind the contact point from we go back to the feel standpoint, just adds a little bit of solidity and a little bit of guts to it. So it's a nice sort of middle, as you say, very few people use full blades. I still do in some of my bag, but very, very few players would use that. So from a manufacturing point of view, there's got to be enough demand to make it worth doing.
Yes, I agree, and we didn't do it so far because there was not enough demand really. But who knows, maybe one day we can do that. In any case, it is for us easier than doing this.
Yeah, because it's a very simple shape.
Very simple shape, exactly, and of course if we do it, we would try to do a blade different than what is on the market, that's clear, but we'll see.
It's hard to reinvent the wheel.
It's hard to reinvent the wheel, yes, exactly.
And I guess then progression of products over the years, so move from these, the one I think that really deserves some conversation, the ADW1. Now this, on initial inspection, looks, you might say, well, what's so special about that? It looks not dissimilar
I agree.
Not dissimilar to the NRB2, very, very similar indeed.
Yes.
However, Gianni and I know that it's a very different construction.
Yes.
The internal workings of this head are totally different.
Yes. Yes, the construction is totally different. I have to be very sincere, and I never thought I would have to do something like this. But as you know, some years ago, somebody came to the market with the idea of producing a sort of a forging and a sort of face, welded face with different materials, and then for reasons that not probably everybody knows, but I know, the cavity was filled with foam, you see, and again, some of our customers come to us and say, it is fashionable now, you have to have something like this, and then, my idea is, well, if we do it, no way I'm going to do something like that. I mean, I have a different mechanical and metallurgical education than doing something like that, and then we studied and we put down our head to design something different, and we came up with this construction, which is a fully forged frame, exactly like our other products, and with the same technology and same principles, if you want. And then I decided to use a particular type of alloy for the face, which is, in simple words, a harder face, of course, but with certain properties of elasticity, you see, and instead of laser welded like some other people do, we use a completely different process, which is a classical process coming from welding of aerospace components, so that we don't have heat affected zones around.
Yep.
And then my idea was to produce a vacuum chamber, which we did, and with our simulation programs, we could calculate that the working phase at a certain thickness combined with the vacuum chamber is producing is enhancing the I don't like the term, but the spring back effect, if you want.
Yeah.
You see, in any case, is changing the coefficient of restitution, in other words, and it was a success because it worked.
Yeah, and the vacuum chamber, just so people, is not the place that it's made. It is within here. It's within the construction of the face.
Yes.
Is there an image on here that may?
Yes.
Let's go to Gianni's. Find the. I've clicked the wrong button. Bear me one moment. Take that off. We can come onto here. So I will.
That one.
Sorry. Yeah.
Yeah.
So use
That's it.
So the image on the screen there, between the orange and the green, is the vacuum chamber.
Correct.
Yeah.
Yes, correct.
Which
correct.
strikes me as a very complicated way to make a golf club.
Yeah, it is a complicated way to make a golf club, and you are right. I mean, again, no secret. I mean, if a company is really wanting to produce more economically, there is no way to go to a construction like this, because it is complex and the process is complex. But for me it was a challenge, and I took that technically until we really made something which works well. I mean, we have produced several runs. We have customers worldwide really liking that, and we are happy to have it, you see, and we are thinking about doing something else in the future, and not at last. If I may add, Simon, is that our experience here also encouraged us to produce fully forged hybrids and fully forged woods.
Yeah. And so, because a lot of the other products, the infill, the foam fill, the principle of that was to support the face.
Thank you.
To, I guess, to reinforce it somewhat without losing the.
Or I shouldn't say to lie. It was to damp the vibrations
And feel, yeah, the feel element to it.
You see, and I have to say that I come from an educational background, not to damp vibration, but not to produce vibrations.
Yes, yes, right, to try and fix a problem that's been created by the manufacturing process.
You
in the
understand
first
what
place.
I mean? You
Yeah,
see,
absolutely. So if I can get the screens back to where they should be, and then I can hopefully we can then get rid of. Should be. Well, it's not clicking off that, but we can worry about that another time. So you mentioned about coming into the hybrid and the wood heads. Would that would be again using a different alloy altogether to the iron heads? I mean, it's a totally different construction.
You mean for hybrid and woods?
Yes.
Yes, yes. To do that, again, it is probably, for using a non-technical words, our craziness level, which pushed that to do that, to produce, first of all, fully forged hybrids. The head is made of 3 different alloys, welded together, but fully forged, not bent, forged. And based on the success of the hybrids, then we could manage to produce fully forged woods. We have a 3 and a 5 wood, fully forged, and again, it works very well. And you see, and our customers, fitters and customers playing with them, they come back to us with good feedbacks, in the sense that, you know, the feeling they have and the sound and the ball flight and ball speed is different than what they were they were accustomed to before, in any case, you know. So we are happy with that. Again, I don't know whether I should really put it in this way, but if we would really sell them at the right cost, it would not be very easy to sell them, considering that our production is not in tens of thousands, it's in a few hundreds, of course. You know, we want to be a sort of a boutique rather than
to achieve the tolerances and the quality of product. It makes it not viable to go to large volume.
Yeah, exactly. You know, so yes, you're right. I mean, we try to produce something special for people enjoying playing with something special in their hands. That's the idea, you see. And after 10 years, we know better what our fitters really want from us. That they want something which is not made by everybody else at the end, you see.
And I think we're one of the elements of the process itself. Even with a head like the NW Pro, one of the characteristics you see from the quality of materials and the quality of the process is without using any, for want of a better phrase, springiness or kind of flexion of the face, is actually better energy transfer, better ball speed relative to club speed. And is that, I guess, is that the materials itself or the production itself that can achieve that?
Combination of the material grade and the process, definitely. Yes, surely. I cannot go into details for the process, but in any case, yes, you are absolutely right. Materials and process, to make sure that you have a component which doesn't only give properties, but gives a uniformity of properties.
Yeah.
In fact, this is something that, you know, independently of my words, everyone can test. I mean, you can hit the ball on the sweet spot, on the peripheral spot, or near the hosel, but you see that the sound is always the same. And the sound, we are not producing sounds, we are producing properties. But I must say that the sound is a result of properties in any case. And if you have the same sound, you can be sure that from one portion to the other, you have the same properties.
I think that's worth what we'll actually do is I'll put a shaft into these and hit a couple with the more kind of the more traditional shaped head, and then with the hollowed cavity to see, just to display the similarities. I think in terms of how the feedback, the feel, as golfers would describe it.
Fantastic.
And as someone who's played the very traditional forged Japanese clubs pretty much whole playing life, I think that's an aspect which has always impressed me with them. So, this one is the NW Pro. I'm just going to hit a couple, and so it's a very clean. maybe with the size of it, I can click off of it, but there we go. That's about as far as my technical knowledge goes.
Fantastic.
So, very, very traditional head shape construction. Considering I haven't moved for about an hour, I'll take that.
Well, fantastic.
And this is with a fairly firm ball. If I go to a slightly
straight,
softer, if I go to a slightly softer ball, because that's actually quite a firm, the Preview 1X, quite a firm ball. What we'll find is a little bit low on the face, but there's looking at that actually for one that's very low on the face. That efficiency, that smash number really hasn't dropped off too much. My left finger knows about it because it's a bit of vibration through the shaft, but I'll do one more here.
Good.
But there's very little differentiation in terms of result off the club face.
Incredible, huh?
Which is
And
really
straight,
the key thing.
fantastically straight. Probably, I must say that the player is the right player to
I'll take as much credit as I can.
No.
Yeah. But what I'm now going to do is put on, now the ball will go further because the loft's different, but we've also got the face tech as well, that I go to the, one could describe as the extreme of the ADW1. We've got that, vacuum filled face. And one of the things that won't really change is the sound. So because there is a cavity in there, there's a little bit more noise, which is inevitable, but it's not the harshness that you get from other components which
Smash
have...
factor 144.
Yeah, and so you've got that extra ball speed and energy off the face immediately. But without, and so people talk about feel, without that kind of tinniness that often comes from where a face has been welded in, where you've got other materials like tungsten in the heel and the toe, that all affects the feedback and the responsiveness. So that was probably hit even better actually.
145, very good. Excellent.
So what I'm actually I'm going to get another company's head with a forged frame and a welded face just to get the comparison on sound, because I think it's only fair to your products to give that comparison. So I will go with and this would be, I'm not going to give the head that I'm comparing, but this would be deemed one of the softer heads out there with a similar hollow construction.
Yep.
So it'll be the same ball, same shaft, same everything.
You have the right tester, James, huh? See the ball flight, fantastic, straight and so.
That's that little bit of a, it's a little bit of a harder note. And to say this is a particularly, a brand that is known for its soft feeling heads.
Mm-hmm.
There's one actually very interesting comparison between these two as well, which, so it's a higher pitched note. And this is, again, say one of the softer heads that I could go much harder and it'd be a really tinny, harsh sound.
And it's a blade, huh?
It's the same. It's a hollow construction.
So
comparing essentially with the
hollow construction. Sorry, yeah.
So it's a similar comparison. What is notable is between the last two shots there. Okay, that one came in a little bit lower, but the spin variable versus the two with your head.
Yep.
There's 120 revolutions difference versus 400. So now granted a little bit of that is the launch angle, but one of the things that happens when you add other materials in and you manipulate center of gravity, you manipulate the structure of the head, is that, and we see it across the board, all the other products, is the flight properties vary a lot. Whereas from a fitting point of view, to have a head that has the ball speed gain that the ADW1 has, it's retained the spin. And that's one of the compromises you make when you decide to add or manipulate the materials.
Absolutely. Yes, well, that's really, thank you, that's very important. Yes, I agree entirely.
It is, and it's something that in golf, in ironheads in particular, we're seeing as a more and more of a difficulty from a fitting point of view, is where the drive for distance and speed has come in, and the extra, the thinner faces, going for what is talked about as going for thinner, faster faces, tungsten the sole for forgiveness to lower CG. We're seeing that spin number becoming more and more and more of a problem. And lofts have got lower, so the ball's coming out flatter. So you're ending up almost stopping at a 6 iron half the time, whereas actually, with the construction of the ADW1, we haven't lost that spin rate.
No.
And so it allows you the performance integrity retains with what you're able to do with the materials.
Very much so, very much so. That's fantastic. That's for me a very important education. I want to say confirmation on what we try to do behind when we design that. That's great. Great to know.
But I think the ball, I remember we saw it when the head first launched, but the ball speed gain without having to add, to say, welds and different materials in. And it's this fascinating education about metallurgy, science of metals, and the application of them all. I think where we have such a, most industries you get into, you have very kind of narrow parameters you work within, but to have our eyes open to what actual industrial forging means and the applications it has out in the wider world outside of golf.
Very much so,
so fascinating in terms of what
plus
can be
you see
achieved.
that due to our experience in producing aerospace component, when we talk about weld, for us, weld, it doesn't mean, how can I say, bringing parent material. I mean, our weld is exactly as you see in this scheme. I mean, there are no welded, parent materials used for welding. So it remains totally pure.
Yeah.
And when we weld, we are not affecting the parent material. In other words, we are not dealing with what we call heat-affected zones. We are changing the properties in any case, you see.
And that's with the other constructions, you're getting the heat that's applied to create the join then affects the structural integrity of the base materials.
So it is exactly like this.
And then the consistency.
And then the consistencies and then transmission of feeling and so on. I have the clean conscience to say this is a pure club in any case. That's important.
And to those in the terminology, it's a very Swiss-made product.
Yes,
the
we try to.
The detail, it's what your countrymen are known for.
Yeah,
so,
I have to add something. I thank you for the compliment. Yes, but I have to say, it is a Swiss design product designed by someone with a British background, with a British educational background. I have to add that. Really, it is like this. Yes.
And I guess future-wise for Gimar, for the products, we know there are a couple of products in development at the moment, sort of, I guess, approaching the back end of.
We will come out in a few weeks with a new product, which also correspond to a very good extent to the input I had from Simon. And from my friend at Precision Golf, of course, and James. And we are also coming out with a new series of wedges, very pure, with the main characteristics in the terms of bounce, lofts, and lie of our FCV4 series. And that's it for the moment, and of course, we keep our radars open for any of your inputs. In any case, I can only learn from you.
That's one thing Gianni's always been very open with is asking ourselves and other fitters what we'd like. It's rare a brand will ask you what you'd like to have as a product. And it's always so, we really appreciate the opportunity to input and at least have some kind of input into what we feel would be a good adaptation to the line. And so, having had a bit of a glimpse into one of the products coming, it's certainly building on the strengths that you've got in the products here, and so it's great to be able to collaborate with you on these, and to have the opportunity to do that with the person behind everything rather than kind of a standard representative is such an opportunity.
Thank you.
It's
Likewise.
fascinating to learn so much as well.
Thank you so much. But for me, likewise, you see, I can bring our metallurgical and forging experience, but I need the right input because you see, I mean, you're coming from the front, from the user front, and your inputs were and are, and hopefully will be for us very important. You see, and really.
Well, thank you so much. Thank you so much for your time and
sure.
for
My
your
pleasure.
expertise. It's always
Pleasure.
fascinating.
Thank you so
Anytime we
much.
spend it here, we learn so much, and we can't wait to see the new products.
Thanks.
And anyone who is interested and wants to know about the products, let us know. Come and test them and see for yourself
Thanks
the
so
benefits of a precision forged golf
Thank
club.
you, and I'm
Gianni,
very happy to be so well represented in the Lano area. I couldn't have more luck than this. That's great. So.
Very kind.
Thank you,
Gianni. Thank
sure.
you.
Thank you, Simon, and thank you very much.